Hi, my name is Chris Yoder, and I'm going to be showing you how to do right triangle trigonometry. For the first problem, it's telling you to measure the height of a farmer's silo. The best way to do this is to start out by drawing a picture. It doesn't have to be necessarily to scale, but if it helps you to write it that way, then by all means go ahead. This is your right angle. It tells you that from a point 47.3 meters from the base of the silo, so that'd be this side, you look up at an angle of 53 degrees. That gives you this angle. And now that you have this, that is all you need to solve the rest of the problem. Because it's asking for the height of the farmer's silo, we'll use x for that side. And then we know to use tangent because we have the opposite and the adjacent values. So you would write it out like tangent of 53 equals opposite, which is x, over 47.3. And then you would solve. And that would end up giving you x equals 47.3 times tangent of 53. And when you plug this into the calculator to get an approximate value, you would get x equals 62.77. And obviously, because the problem prompts with meters for the length and we're trying to find the height of a silo, you would want to add your units. Problem 2 is a little different because it doesn't give you a angle measure. It actually is having you solve for an angle measure. So it says that your cat is trapped on a tree branch 6.5 meters above the ground. So obviously we know we want to draw our picture. And since it's 6.5 meters above the ground, we know that it's this value. And then since it, it also says that you find a ladder that is only 6.7 meters long, and we know that that's the hypotenuse because it's the ladder against the house is just common. And it's asking what angle the ladder will make with the ground, and that is this angle. So that's your theta, and this is what you need to begin solving. Now, because we have the opposite and the hypotenuse values, we're going to be using sine. So you would write it out like sine of 6.5 over 6.7 equals theta. And then when you plug that into the calculator to get an approximate value, you would get theta equals 75.97 degrees. Problem 3 is asking you to find it's asking you two questions. It's asking you to find an angle, and it's also asking you to find the hypotenuse. So once again, we're going to draw our right triangle picture. It tells us that the base of the volcano is only 30,000 feet from the ocean. So this is 30,000 right here. And then it also tells us that it is 10,000 feet high, the peak, and I believe that is right here. And so we use this. It's asking for part A is asking for the angle you would have to look up to see the peak if you were standing at the beach. That'd be this angle. And then part B is asking for the straight line distance from the beach to the peak, which is the hypotenuse. And this is what you need to solve the problem. Let's start out by solving for A. A is asking for the angle you would look up at you would be looking at if you were standing on the beach and you wanted to look at the peak of the volcano, and that is solving for theta. So we can write this out using our tangent values because we know that we have the opposite and the adjacent values from the angle. And so you would write it out as theta equals 1, you could write it as 1 over 3 because as long as the ratios stay the same, the tangent values will be the same. So, hold up, let me. Tangent of 1 over 3. And that just because these both reduce by 10,000. So if you just divide both these by 10,000, you would get 1 and 3 and it would be the same. It just saves us a lot of time typing out and writing out the zeros. And when you plug in the calculator for that approximation, you would get theta is equal to 18.43 degrees. Part B wants you to solve for the hypotenuse. So for this, we're going to use Pythagorean theorem. Now, when you plug it in, you'd plug it in as 10,000 squared plus 30,000 squared equals c squared. And when you solve this, you would see that after you plug it into the calculator, you would get this value. And then we know, because Pythagorean theorem, we have to square this value in order to get our answer. And that gives us approximately 31,622. Let's write this out. C equals 31,622.7766. And that is our hypotenuse value. Don't forget to add your units at the end. Alright, for the fourth problem, it is also asking two parts. It is asking the height and how far from the observer. Okay, so it tells you that an observer is 5.2 kilometers from a launch pad. So the observer would be over here at this angle. So 5.2 would go down here. And then at a particular time, the angle of elevation is 34 degrees. So that's this angle. So we know that a missile is ascending, and we know that somebody is watching it from a launch pad, or watching it from 5.2 kilometers away from the launch pad. The first part is asking us how high the missile is. So A, and how high the missile is would be this side. And so we solve this using our tangent values, because we have the opposite and the adjacent values of the angle. So you'd write it out as tangent of 34 equals x over 5.2. Now, obviously, we can't just plug this into the calculator and get a value for x. We need to solve algebraically. So an easy way to do this is to just isolate the variable as you're used to. You have to multiply 5.2 times tangent of 34 to get your x value. And when you plug that into the calculator, you would get an approximation of 7.95. Also, don't forget your units. Part B is asking how far the missile is from the observer. This is our hypotenuse. To find it, we have to use sine, because now that we have this side over here, we can use it. We can use opposite and hypotenuse. So you would write this out as sine of 34, right here. Sine of 34 equals 7.95 over y. Once again, you have to solve algebraically, and this is one extra step. Let me label this real quick. This is one extra step because of the nature of the problem. So you would multiply y by sine of 34. Let me write that out. And then to isolate the variable, you would divide by sine of 34. So y equals 7.95 over sine of 34. And when you plug this into the calculator, you get an approximation of y equals 15.03. Our final problem tells us that a team is building a zip line through the skyline of Atlanta, and they have 125 feet of steel cable for the zip line. They've been told that the maximum angle of decline can only be 42 degrees, and it's asking for the maximum distance the two buildings can be apart. Let's draw our picture. Now, because the maximum feet of steel cable they have, so that'd be the hypotenuse, because that's the length of the zip line, steel cable, and the angle of decline is 42 degrees. Put that down here, and this is what we need to solve, is the maximum distance the two buildings can be apart, so that would be down here, and we're just solving for x. we know to use cosine because we have the adjacent and the hypotenuse values. So we can write this out as cosine of 42 equals x over 125. And to solve this algebraically, you know to multiply 125 times the cosine of 42. And when you plug that into the calculator, you would get an approximation of 92.89 feet.